Welcome to the Technical Explainer video for Project Mandala. In this video, we will take a deep dive into the back end of the Mandala proof of concept. We'll explore the components of the systems, their workings, and how the participants interact with the system with the help of a real-world use case in this video. All participant institutions, commercial banks, central banks, or any other regulated financial institutions run a Mandala node in their system. These participants interact directly with each other via a peer-to-peer messaging system, eliminating the need for intermediaries. Communication between nodes is encrypted, ensuring data security and confidentiality. This facilitates participants in obtaining relevant policies that apply to a transaction, transmitting encrypted data necessary for generating a proof of compliance, sharing the generated proofs, and handling any other communication essential for automated compliance checks. The next critical component of Project Mandala is the rules engine. Mandala systems hold policies in a comprehensive policy library, which standardizes the representation of policy and regulatory measures across different jurisdictions. The system also provides templates, offering a structured format for ingesting new policies and regulations that are then converted into machine-readable data. This standardization allows a vast number of differing measures from various jurisdictions to be encoded as rules within the system. These rules are stored in the rules repository. From that repository, the pertinent rules can be retrieved and automatically displayed as a dynamic compliance checklist based on the bank's transaction inputs, and ultimately applied against the consumer data for the relevant compliance checks. Based on the transaction details of an incoming payment request, the rules engine retrieves the relevant policies that apply to this specific transaction. The core component of Mandala, the proof engine, then performs the checks. For each relevant rule, the proof engine conducts the necessary checks using client data, transaction details, or, if necessary, communicates with other Mandala nodes like the beneficiary bank. And where communication with other nodes is required, Mandala provides ways to complete these checks in a private manner using techniques like zero-knowledge proofs and multi-party computation. Compliance proofs are then integrated into the asset transfer system, providing evidence that all necessary compliance checks have been completed. This ensures seamless and faster value transfers. Let's see how the Mandala system works with a real-world example. A Korean battery company, K, sources its lithium from Australian company A. To boost production, company A needs additional investment. Company K agrees to finance this by purchasing A's convertible bonds. The payment for these bonds includes two parts. A portion is offset or netted against payables between companies. The rest is paid through a cross-border interbank transfer. Now, let's focus on the cross-border interbank transfer for this purpose. In this case, the originating bank is the Korean bank, and the beneficiary bank is the Australian bank. An officer at the Korean commercial bank initiates a compliance check for a transaction using the Mandala interface. Based on the purpose of the transfer, acquisition of securities, the payment type, netting, and the currency, US dollar. The rules engine retrieves the applicable policies. The originating bank can also communicate with the beneficiary bank directly to obtain the relevant policies if not available. The system checks the client and beneficiary details against public sanctions lists and, upon successful completion, generates a zero-knowledge proof. This proof is tamper-proof and allows any party in the payment chain to verify that the check was completed without revealing the client data used in the check. For the beneficiary's private sanctions list, the client's data and the beneficiary bank's private sanctions list are compared using secure multi-party computation to ensure privacy. The results are digitally signed by both parties and mapped in their databases against the compliance check ID. These examples show how Mandala can perform checks while preserving privacy between the transacting parties. The compliance check ID is embedded into the SWIFT message, such as a PAX 008, which is used for the credit transfer transactions between customers. Every institution in the payment chain can read the compliance check ID from the SWIFT message and access their Mandala system to retrieve the proofs. This allows them to verify that the required compliance checks have already been completed, enabling them to forward the message without performing additional checks at the time of payment. This process is repeated for each institution in the payment chain until it reaches the beneficiary bank. This approach aims to reduce payment processing time and minimizes the risk of payment failure while ensuring compliance across jurisdictions.
The proof of compliance can also be used in a tokenized payment system. To showcase this, let's assume another real-world example. A Malaysian company borrows from a Singaporean entity. The rules engine retrieves the applicable policies. The public and private sanction list checks are conducted the same way as described before. Additionally, Malaysian capital flow management measures apply for this scenario. Through a multi-party compute approach, compliance with the CFM measures can be checked with Bank Negara Malaysia without revealing any of the underlying data. A signature of the central bank is then added to the proof set. Let's explore how proofs are incorporated and verified within a digital asset settlement system using tokenized Singapore dollars.
The process starts with the originating bank in Singapore, which wraps the SGD with a smart contract policy wrapper. This wrapper breaks down each proof in the proof set and sends them to the appropriate verifier contracts. These verifier contracts are deployed on the same chain as the policy wrapper, with each policy having its own dedicated verifier contract. The verifier contracts check that hash of the public sanction list matches the latest version, the content of the signed message is correct, and the signatories are authorized. Once the verification is completed by these contracts, the wrapped SGD is transferred to the Malaysian bank's account. The beneficiary bank then checks that all proofs have been successfully verified, upon which the SGD token gets unwrapped and credited to the beneficiary bank's account, ensuring the transaction is secure and compliant.
In summary, the Mandala POC introduces key efficiency gains, such as increased likelihood of straight-through processing, automated compliance procedures, programmable compliance for tokenized assets, reduced reliance on intermediaries, enhanced end-user privacy, transparency around cross-border transaction policies. We hope this presentation has given you a comprehensive understanding of how Project Mandala employs compliance by design, aiming to streamline and accelerate cross-border compliance processes. If you would like to learn more, please find the link to the detailed technical report in the description. And stay tuned for more updates and innovations from our team.